Preparing to live stream the meeting. Okay, so we are now live in YouTube, but this link of YouTube is not open for public. I'm giving you the link for the YouTube, so if you feel difficulty to follow my class in Zoom because of your connection, you can also follow in the YouTube channel, yeah. But if you have any questions, I hope you can put it in the Zoom meeting. Okay. Preparing to live. Okay, so let's start. Okay, can you see my slide well?
Yes, Miss.
Yes, Miss.
Okay, so today we are going to have a quick look and overview about the seafood processing as part of the core subject in animal-based food processing in Food Technology Swiss German University. So before we start, I want you to know that 40.5% of the world seafood is consumed fresh. Yeah, so you buy it in the wet market and then cook them. But 45.9% of the world seafood is being processed, either frozen, cured, canned, and other traditional processing. Now, what this percentage correlate to a number is that we have currently more than 155 million tons of seafood that is being produced each year. So 45.9% from that number of seafood is actually quite large. So this is why we thought that the seafood processing is also an important aspect to be learned in food technology. Now, before we begin, we should bear in mind why do we process food? This is because we want the food to be safe, from spoilage and also from contamination. First, we will talk about the seafood spoilage. You know that the seafood deteriorates very quickly due to various factors. The first and probably the most significant spoilage is microorganism spoilage. Seafood plus has a high amount of non-protein nitrogenous compound, or we call them NPN. Also have low acidity. Yeah? The pH is quite neutral, more than 6. This support the fast growth of microorganism. And you have learned that in a living thing, including the seafood, they have endogenous enzymes. And immediately following their death, autolysis will follow. And this autolysis may came as the action of endogenous enzymes. And this action of endogenous enzyme and the autolysis, it causes loss uh, in the fresh fish character, such as the fresh odor, the textures of the fish, also the taste of the fish. Another factor that may contribute to seafood spoilage is chemical oxidation. This is important spoilage mechanism, especially in fatty fish. Now, other than spoilage, we also want the seafood to be safe for various contamination. Just like the spoilage, we have microbial and then chemical, uh, microbial and also chemical hazard. So if we take a look into the micro contamination, in the environment, there is bacterial pathogen. There are bacterial pathogens and viruses that were naturally present. And also, the aquatic environment can be contaminated with virus and some bacterial pathogens. This microbial contamination may also contaminate the seafood during processing. Here, I give some example. The naturally occurred pathogen in the aquatic environment is like the pathogenic Vibrio, Clostridium botulinum, Aeromonas hydrophila, yeah. And then some contaminants that may come in the environment is like the pathogenic Escherichia coli and also Salmonella species. And then during processing, microbial contamination may also occur, such as in the occurrence of Staphylococcus aureus and Listeria monocytogenes. So the processing of seafood mainly control this microbial hazard. But there are another hazard from seafood, which is the chemical hazard and biotoxin. Yeah. Some of the famous biotoxin is like the diuretic shellfish poisoning. Yeah. So if you eat shellfish, and also the paralytic shellfish poisoning, neurotoxic shellfish poisoning, and also the amnestic shellfish poisoning, and fish ciguatera poisoning. Some of them have been discussed in the food chemistry class on semester 3. Most of the biotoxins is here is in the shellfish. Also, chemical contaminants such as heavy metals. Those are some hazards that have been pointed out in shellfish. This is because shellfish, yeah, it work as a filter for the aquatic environment. So many of the chemical hazard and toxin might accumulate in the shellfish. And this biotoxin and chemical contaminants, it can be controlled, but the control should be applied mostly during primary production and the pre-harvest stage. For example, with the water treatment and also the control of the water quality. Now, if we talk about getting the optimum quality of the raw material, then we will be talking about pre-mortem handling. You have learned previously about rigor mortis, yeah, and how animal stress, not only fish, the animal stress may affect the rigor mortis. This is why in the handling of fish, rapid killing is always suggested. It will reduce the stress and therefore improving the quality of the fish flesh. Another factor for fish is the application of the starvation technique. So usually few days prior to the slaughtering for the fish, yeah, the starvation practice is being applied to reduce the amount of feces in the intestine. This has been shown to delay spoilage in fish because the digestive tract of the fish contain high bacterial population. Also, it contains digestive enzyme that result in the post-mortem autolysis and the strong of odor in the abdominal area of the seafood. Now, lobster and crab are usually keep alive as long as possible because it was shown that even though they were stored in a chilling temperature or in ice, if the lobster and crab was killed, then it spoiled rapidly after their death, even with the low temperature storage. So usually in the pre-mortem handling for lobster and crabs, the idea is to keep them alive as long as possible. Now, if we talk about shellfish, I have mentioned before, they are filter feeders. So they can concentrate contaminants from the aquatic environment. The best way to get the optimum quality from the shellfish is to have the optimum quality of the water, their water environment. So the water quality, water checking, water maintenance, water treatment is usually the most important factors to get the optimum quality for the shellfish. Now in post-mortem handling, yeah, there are several objectives for this post-mortem handling. One is, of course, for shelf life and food safety, the basic and the most important, because the processing of seafood is inhibiting or inactivating the bacteria and enzyme. This is very important in the shelf life and in the food safety. In addition to the shelf life and food safety, the processing may create a convenient and added value to the seafood product. A range of processing method can be used to preserve seafood, and the different variation of this processing method give a special organoleptic characteristic, give a special nutritional value as well. So you see the same fish, if you smoke them or you fry them or you ferment them, it will result in a different type of food, different organoleptic character, and different nutritional value. Now, if we talk about the post-mortem handling, mostly we will talk about the primary processing. Now, before further sophisticated processing, often fish and shellfish must undergo some type of handling or primary processing such as washing, cutting, filleting, and sucking. Yeah. A note in the post-mortem is that the onset of rigor mortis highly affecting the quality of the fish. So in the onset of rigor mortis, we know that the relaxed and elastic muscle become hard and stiff. So the post-mortem handling usually always considered the onset of rigor mortis, whether to do it before or after the rigor mortis. Now, according to risk contamination and the processing method, seafood can be classified into 7 groups. The first group is mollusk. These are the category which have the highest risk, especially those that are to be eaten without cooking. The second one is the fish and crustacean that will be consumed after cooking. This still categorized as the medium risk, lower than the mollusk, but still quite risky, yeah, because it has a fresh period without processing period for quite long time before being consumed. And then you have the third group is the lightly preserved product with the salt content less than 6%. And the pH usually is still quite high, which is above 5. In the fourth group, you have a semi-preserved product. The semi-preserved product have a higher salt content than the lightly preserved. The salt content should be above 6%, and the pH should be lower than 5. And then in the fifth group, you have a mild heated product, which is like pasteurized seafood, hot smoked seafood. Those are those has a lower risk compared to the above them, but not that safe. Yeah, it still have a quite short shelf life. And then in the lowest risk for the seafood, you have a thoroughly heat processed product, and also the dried or the dry salted and smoked dried seafood. This last group is categorized as a very safe seafood to be consumed, yeah, and it tastes good also. Uh, in the processing, I will talk. There are various kind of processing, but I will only highlight several type of processing. One of them is cold storage. Why? Because this is the simplest way to preserve seafood. The rapid chilling of fish is important, not only to inhibit bacterial growth, also to manage the onset and duration of rigor. So the onset of rigor mortis depends on the difference between the sea temperature and the storage temperature. So you probably see that when people are transporting fish, they put the back of the water, they take the water, some part of the water from the environment where the fish were grown, and then adding some other water. So they have the not shocking temperature, yeah. So because when the difference between the temperature of where the fish is being harvested and where the fish is being storage is high, then the onset of rigor is also fast because of the stress, yeah. Now in the cold storage, the key point is to inhibit bacterial growth and, and to manage the onset and duration of rigor. The standard procedure for the cold storage is chilling in ice. Yeah, it is usually applied for the whole fish, especially after harvesting and killing, and then also refrigeration. This is usually applied after the fish is being gutted or filleted. uh, Now the extension from that standard storage could be freezing and then super chilling. The super chilling is chilling but with quite low temperature. Yeah, usually chilling happen in the 5, 10, 12 degrees Celsius, but the super chilling is conducted like few degrees below 0 degrees Celsius. Uh, and then another thing that can be done for the shelf life extension is combination of chilling with uh, MAP, modified atmosphere packaging. This modified atmosphere packaging that commonly applied is the reduction of oxygen and the increase of carbon dioxide. The technology of this cold storage is quickly evolving. Yeah. For example, in the last thing that I've mentioned, the application of modified atmosphere packaging, and then the minimal heat processing, and then in the rapid freezing, and so on. So I hope you keep on the update of this cold storage technology. Some note about the frozen fish filleting. The filleting is usually performed before or after the rigor, not in the rigor, because in rigor it will produce fillet with capping and give the lower yield. So whole fish and the fillets, uh, it is when it is frozen before the onset of rigor, it can give various advantage and disadvantage. Yeah. For example, there is a study when pre-rigor fillet of Atlantic salmon were observed. The filleting prior the rigor showed that it um, showing that the fish have a lower bacterial number, and also the other flavor, yeah, the sensory characters were better. It has higher score for the odor flavor, and the gapping was lower also, but the water loss was higher compared to post rigor fillet. So the decision to fillet prior or after the rigor is usually determined also by the species that you want to process the fillet with. Later, I will show you some video about the fish filleting that is in combination with the refrigeration process in the industry. Yeah. Now, other seafood processing that we will be discussing after this class will be you have a big circle here, but heat processing, yeah. This is the major method for extending shelf life of seafood. It has a high level of safety and convenience. And then you have a lot of other processing such as drying, canning, salting, also the traditional processing such as the fermentation, marination, smoking, that create the variation of seafood products. Yeah. Quite considerable amount of fish is being used in the surimi production. So we will take a look separately about the surimi production and its important in the seafood processing. This surimi is a fish protein concentrate that have a gelling ability, so it has a chewy textures when you eat them. And the surimi is used as an intermediate raw material for food production. It can be further processed into surimi-based products such as kamaboko and crab meat and lox. And then a big point here is the fish waste treatment. Uh, we will take a little bit look for this because this has been an emerging importance in the food technology. The seafood industry consumes a lot of energy. It produces considerable amount of waste. So there's a higher concern about sustainable operation. Also about its waste treatment and disposal, the recovery of the byproduct, and the energy efficiency and water usage. What does this got to do with us, food technologies? Is because in the development, uh, technology have emerged to treat to convert this fish waste into useful products such as feed, natural pigment, and also food for human. Yeah. So we will take a look about fish waste treatment in the next lecture. Please wait for it. Yeah. Please look forward for it. Also, in the seafood processing, we have the emerging technologies such as irradiation. This has been very effective to increase the shelf life of the seafood product. Also, the high pressure processing, the high pressure usage reduce the requirement for the temperature usage. So this high pressure processing for high value seafood product is being applied and will be more widely applied because it may maintain the sensory character of the seafood product. Also the radio frequency heating, and then the flexible retort packaging, and the pH safe processing, and so on. Yeah, so there are a lot of updates in the seafood processing. So I hope this lecture is uh, only a bait. Yeah, and it can make you become curious with the other processing technology and look into it more. Now, an important aspect in the processing is the safety and quality. Freshness and quality of seafood is usually assessed using a sensory, microbiologically, or chemical method. But recently also the risk assessment in hazard analytical critical control point is widely applied because this has improved control and evaluation of seafood hazard, and the application of HACCP HACCP, yeah, it lead towards integrated approach of food safety. Yeah, this has been very important in food industry. Now, if we take a look about the quality control method, you have the sensory. The sensory assessment is subjective and it requires highly trained personnel. But I will introduce you through a video, just a glance about how you do sensory quality control for the seafood later, yeah. And also, microbiological assessment. The microbiological assessment, like traditional culture technique, is slow, yeah, and laborious. But despite the disadvantage, they are still considered as a standard method for the seafood safety. The recent updates about this microbiological quality assessment is the application of advanced in molecular microbiology method, and also the automated rapid method for quick and reliable analysis. In routine use, yeah, in routine use, usually determination of chemical spoilage parameters such as TVBN, total volatile base nitrogen, and TMAN, trimethylamine nitrogen, are commonly used. Why? Because this TVBN and TMAN is a parameter of microbial growth. So when the microbes grow in our seafood, they will be producing this TVBN and TMAN. So it is faster, yeah, to check their this product that is resulted from the microbial growth. In the technological updates for this chemical quality assessment, currently there is development of using other metabolites that is non-nitrogenous volatile as also the chemical parameters. Also, there is a usage of Physical, automated, and non-destructive instrumental methods such as FIS or NIR spectroscopy and electronic nose to evaluate the chemical spoilage parameters. Now, screen time, yeah, you can grab a bag of popcorn and choose your movie for the frozen fish filleting, fish canning, and then surimi and seafood QZ and QA. I give you in the Google Classroom for some video about it, so you can take a look at it. Okay, thank you. Do you have any other questions? Do you have questions?